Hello world, October 17th. All right. To do it, count number of maximum bitwise OR subset. Given an integer array nums, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. An array A is a subset of an array B if A can be obtained from B by deleting some, possibly 0 elements from B. Two subsets are considered different if the indices of the element chosen are different. A bitwise OR is a bitwise OR, right? Okay, so we have an array and we want to find the maximum possible bitwise OR of a subset of nums. Okay, a subset of nums, and then return the number of different non-empty subsets with a max. So we need to first find the maximum subset OR, right? Oh, nums length only 16. That changes stuff. That basically means the runtime is probably 2 to the n, right? Okay. Yeah, I think it's just like either I pick this or not pick this type of thing, right? So I can say I can pick the first one or not pick the first one, pick the second one or not pick the second one, and then we basically go through all possible, yeah, because num is only 16, so we go through all possible subsets, right? All different types of subset, and basically it's the question of what is the Yep, that's fine. That's fine. So all we need to do is it's just a question of finding all the combinations. Right? It's finding all the combinations of the whole thing. Okay. So how do we find all the combinations? Well, we can say there is a way using bitmask. Right? Using bitmask. And we'll go through the bitmask and we will only use the ones that's okay. So if we use bitmask for this, let's see, we use bitmask. So bitmask is a very easy way to do all combinations. So we get the length, and it's gonna be 1 left shift that. So length is 3, so 1 left shift 3 minus 1, right? So basically we say for int bitmask equal to, I think, from 0, which we don't choose anything. You don't choose anything. If you don't choose anything, then you'll be 0, which is not. No, you have to. Oh, you have to choose something because it's non-empty. Okay, so we'll choose this bm, which is smaller than, well, smaller equal to 1 left shift n minus 1 and then bm plus plus. Right, it's the mask. I call it bm. I like to call it m. Okay. And then we'll have a res, right, and max OR, max or we set to 0. We can do a private int get or get array or. Alright. Or so res equal to 0. Right. Int I equal to 0, I smaller than nums.length, I plus plus. Okay. If mask and one left shift I, right? If that's equal to 1, res or equal to nums I, and then we'll return res, right? So this we can say int current or equal to get array or nums and m. If current or is larger than max or, then max or equal to current or, and else if, right, then res plus plus. If it's smaller, then we ignore. So it goes through everything and then we'll return res. Okay, let's give this a shot. Ooh, that was not right. Huh. I have a mask is 1. Shift. Interesting. What goes wrong here? What's the current or? 0. Huh. M equal to 2, right? It should be 1 0. M equal to 2, right? Mask is 2, which is 1 0. And then 1 0, right? And then if it's 0, that equal to 0. But if I equal to 1, 1 left shift 1, yeah, that would be 1 0. 1 0. Oh, I see. It's not equal to 0. My bad. My bad. There you go. I got that one wrong. I'm pretty confident. I think this one will do. Since the length of nums is no more than 16, we are confident that the solution is brute force. So we find all possible subsets of nums, compute their array bitwise OR, and find the frequency of the max count, the max bitwise OR. Well, technically, times n. Oh shoot, maybe this one will. Oh, this one might. I don't know. Will it? Good question. 2, 3, 4. What a timeout. There is a possibility that it will time out. Oh, okay. That's pretty lenient. It's very lenient on the time, so yeah, it does not time out. Pretty lucky. Recursion. Let's see. Count max. Wait, hold a second. Oh, we have a target. Target is. Oh, really? I didn't even think about like what the target is gonna be. The target is going to be. Oh yes, yes. I didn't even consider this. Yes, the target is you exclusive you or everybody. That's the target, and then you just run a recursion. Yep. You go to the end. Current or. I mean, think about how you need to do recursion. Yeah, either you pick it or don't pick it, right? So recursion will be either you pick it or you don't pick it. We can actually try it. Yeah, we can try it. I did not realize that it's actually straightforward. I did not realize that the max or array OR is deterministic. It is the result of all in everything in nums. Thus, we can use recursion to do this problem. All right. Okay, so we can say private int count. We have count, we have an index, current or max or. Right, so we say if index is equal to nums.length, we have do the entire thing. Then we say return current or is equal to max or. If it is 1, otherwise 0. Okay. Otherwise, we are at the current index we have the current or, then we say return count nums index plus 1 current or count nums I index max or plus count nums index plus 1 current or max or. So one is either include the current num or not. So int max or equal to 0 for int n nums max or equal to n. And return count nums 0 and max or. Alright, I'm not sure. Can give this a shot. I coded up very fast. Yeah. Oh. Why is this one faster? I don't know. Because you don't do multiply by n again. Because as you go through, so because this the runtime, you don't have the times n. Wow, this is actually a better solution, I realize. Supposed to be. Oh. Memorization, yeah, you can, definitely can, because you can do this, this and this, right, kernel, index and kernel, which is n times, yep, you can do that. Bit manipulation, I think I did the bit manipulations, did I do it? Oh yeah, you have the times n, you have the times n, unfortunately. Bit manipulation and dynamic programming. Oh. So we have a DP, Iterate through each number in the input array. For each existing subset, create a new subset by including the current number. I don't understand. DP max. Is how many different subset? Okay, I think this is how many different subset. Right, how many different subset can reach So DPI is I is basically the array or value, and then we want to find how many can get into this value, right? So we have each number comes out, right? And each existing subset, create a new subset by including the current number. Existing subset. Huh. So yeah, this everybody in the DP the indexes the indices of DP is all value. So you pick every single one that's possible. You all with a current number, right? And then you get a new value, and we need to know how many times this can be created. So you plus equal to DPI, because DPI is the I. Yeah, then we have DPI number of subsets that has the OR value as I. Now I want to add max. I want to add the num to it. Then we create a new one, and we update its values. And each time we do it, we go from the current to maximum. Oh, that is interesting. All right, that's about it. I think recursion. Yeah, recursion is sufficient. All right, that'll be it. I will see you guys tomorrow. Adios.